This video is all about dilutions, okay? So I want you to have a look at this. Consider a 500 ml solution of salt water, NaCl. If I dilute the solution by adding an additional amount of water, so if I double the amount of water and add 500 ml of pure water, have I changed the concentration? Have I changed the amount of salt present in the solution? So your answers here should be yes, I have definitely changed the concentration. Okay, the concentration should have decreased because I have more water. I have more solute or solvent than solute. So your concentration, your concentration decreased. Okay, have I changed the amount of salt that is present in the solution? I have not. No. Okay, and that's the key to understanding dilutions. I didn't add or take away any salt from the solution. The only thing I added was water. So, if the amount of salt does not change, then the moles remain constant. So why don't you copy this into your notes? Okay, so that means that my moles before, so we'll call that N1. So this is before I added the water. It's going to equal to the number of moles of salt after I added more water. So N1, or my moles to start with, equals the amount of moles of salt I ended with. N1 equals N2. So what we're going to do now is look at our formula for concentration. We know that concentration, C equals N over V, is our formula. If we solve for N and rearrange it, we can show that N is actually C times V. So what we're going to do is we're actually going to take this and plug it in up here 2 different times and get what we call a dilution equation. So if we sub it in, we get that C1V1, or our concentration times volume before I added more water, should equal the concentration times volume after I finished adding my water. And this is what we call our dilution formula. Now the thing that you guys have to remember about this, it seems really easy right now, and it is. It's an easy concept. All we're going to do is plug in some numbers and we should be good to go. The thing that people forget to do a lot of the times is they forget that this is a dilution formula. And the only time I'm allowed to do this and use this equation is when the only thing I'm adding is water. So if I add water to change the concentration, I'm allowed to use this formula. If I add anything else, so if I add more salt or something else to change the concentration, I cannot use this formula. And that's the most common mistake that people make. They will use this formula when we're not adding water. Okay, so that's wrong. The only time we can use C1V1 equals C2V2 is when it's a dilution by adding water. So let's go through an example. I have 2 liters of NaOH, and it's created from using 750 ml of a 2.5 molar NaOH stock solution. What is the concentration of my diluted solution? So when you're doing this, make sure that you are keeping your data consistent. Okay. So I've got something that I like to call the of rule. Okay, and what the of rule does is the word of links 2 numbers together that will have the same subscript. Okay, so I started off with C1 and V1, and I'm asking you to find the concentration of the diluted solution. So that's C2. Okay, and it says that 2 liters of this was created from using 750 milliliters of a 2.50 molar NaOH solution. So here's how the of rule works. Here's the word of. Notice that of has a number before it and a number after it. Those 2 numbers have to have the same subscript over here. So of will link either C1 and V1 together or C2 and V2 together. So that means that my other volume over here must be the diluted one. So this would go over here. So now once we have what's given to us in the problem and what we need to find, we plug in our numbers. So C1 V1 equals C2 V2. Okay. What you have to remember is always convert and have your units consistent. So we have to convert this to just liters. So when I do that, I get 2.5 molar times 0.750 liters equals C2, which I'm trying to find, times 2.00 liters. So if I rearrange my equation and punch in my numbers, I should get that 0.937, oh, I'm running out of room there, 0.9375 molar is my final concentration. Okay, and that makes sense because it is a diluted solution and the concentration here is less than the concentration that I started with of 2.5. So now I just have to go back and make sure my significant digits are okay. So my final answer would be 0.938 molar. Okay, so sig figs and units are very, very important. All right, let's try this example. How much 12 molar hydrochloric acid is required to make 3 liter solution of 1 mole hydrochloric acid? So again, we've got to figure out what is C1 and V1, what is C2 and V2, and usually I'm only missing one variable, and that's the one that you have to rearrange your formula to try and solve. Okay, so I'm making a more dilute concentration here, and this is the more concentrated concentration. So I should put my 12 molar here and my 1.0 molar here. So how much of the 12 molar HCl is required to make 3 liters of 1 molar HCl? Again, if you want, if that doesn't make sense to you, or if you're finding it tricky to figure out, well, is this number C1 or V1, or what is this, use the of rule. So here's, again, the word of. I've got a number before it and a number after it, which is written on the next line. So I know that those two numbers go together. So I put the 1 and the 3 together. They're C2 and V2. Okay, so let's plug in. In this case, I'm asking you to find V1. So C1 V1 equals C2 V2. I'm allowed to do that because I'm diluting my acid. So C1 is 12 molar. V1 I'm trying to find. C2 is 1.0 molar. And V2 is 3.0 liters. Okay, I don't have to convert anything from milliliters to liters in this case, which is nice. So in this case, my V1 ends up being 0.25 liters, or if you wanted to, you could say it's 250 milliliters. So what does that mean? That means if I've got a big bottle of acid, so if that's my 12 molar HCl, I have to take out 250 mils of it. So I would take out 250 mils and put it, say, in another flask or another beaker. So there's my 250 mils. And I would have to add enough water to bring the final volume up to 3 liters. And if I did that, oh, H2O, sorry. If I did that, my concentration will be exactly 1 molar, or 1 mole per liter. All right, we've got one more example to go through. So I've got 500 mils of a 6.5 molar sulfuric acid solution, and it's diluted down to 1.5 molar. How much water was added? So this is a little bit trickier. We've got to take it one step further. So again, let's figure out what is C1, V1, and what is C2 and V2. Okay, so I started off with, here's my of rule. So those two numbers are going to come together. So I've got 6.5 molar. That's my initial concentration. And I have 500 milliliters. So that's the same as saying 0.5000 liters. And it's diluted down to a concentration of 1.5 molar. How much water was added? Now you have to remember that this water here that's going to be added is not necessarily my V2. So let's go ahead and solve for V2 using my dilution formula, and I'll show you what I mean. So C1V1 equals C2V2, so I've got 6.5 molar times 0.5000 liters. That equals 1.5 molar times my V2, so it'll be my final volume of the solution. So I get 2.2 liters equals V2. So what that means, it's not the answer to my question. So if I go back, again, kind of draw you a little picture of what we would do with this in the lab. Here is my 6.5 molar H2SO4 solution. So I go into the back chemical storage room and I pull out that. And what I do is I take out 500 milliliters of that. So when I take out that 500 milliliters of my acid, I'm going to put that 500 milliliters into a new flask. Ooh, this is kind of messy. So I'm going to put it in there. There's my 500 mils. So 500 mils of acid. Okay. And now I'm going to add in water. My final volume, that's this, is 2.2 liters. So how much water did I add? So water added, in this case, is actually going to be 2.2 liters minus the 500 milliliters, or in this case, I'll just write it as 0.5 liters. So because I already had 500 mils at the bottom of my flask, and my final volume was 2.2 liters, that means I only had to add about 1.7 liters of water to bring my final volume to 2.2. So that's just taking the calculations that we do and applying it to a more practical setting. And you will be expected to do that on a quiz or on a test, okay? Just so you know. So that's it for dilutions. Hopefully that's pretty clear. We'll do some more examples together in class.